Hello viewers, in this tutorial session, I'm going to show you how to troubleshoot traffic traversing the file path thread defense using packet capture. Now I'm going to show you how to capture packet on FTD. So we can do it via GUI and at the same time we can do it via CLI. I'm going to click on add capture. I'm going to name my capture test. And let me capture ICMP from source 10.10.20.100 to destination 20.20.20.1, and the interface, the ingress interface, is going to be the inside. This is a packet size, buffer side. You can do continuous capture or stop when full. And trace, I'm not doing trace. If you include trace, that means it's going to run both packet tracer and it's going to capture the packet at the same time. So you see the trace output on top followed by and sometimes you see the packet capture in between. So, but I'm not doing that. I'm going to click on save. So I can also auto refresh and you can disable it. That means every 10 seconds it's going to auto refresh the output instead of you refreshing it manually. And so this is okay, ICMP source destination running. This is edit icon if you want to edit. This is delete if you want to delete. This is clear if you want to clear the output. That means you want to clear your buffer, you want to clear the output. And this is pause if you want to pause the caption. And this is save should in case you want to save the capture. So I'll go to my host. Let me run ping to 2020-21. I don't think that will be allowed. Actually, I think I only allowed ping to 30-30-31. Okay, that's fine. I will run to 30, ping 30-30-30.1. Before I do that, not yet, let me wait for auto refresh. Okay, because I don't want to wait for auto refresh, I decided to click refresh for myself. This is the first ping, which is from 10-10-2000 to 20-20-21. You can see the only thing we can see is just the echo request. We can only see the echo request. We are not seeing the response from the other end because it's not being permitted. That's another thing you need to know. So for example, in most cases, if you are receiving echo request, if echo request is going out and you are not receiving a response, there's no reply coming forth. So it's either maybe you don't have route to that host, to that outside host, or maybe it's being blocked, it's being denied by an access list or access rule or whatever. So those are the two main reasons that usually cause that. Let me go to my access control policy just to prove that we don't have an access rule that is permitting that traffic. So the ICMP rule I have here is only permitting it to 10.30.30.30.1. So let me do that again. Ping 30.30.30.1. That's fine. So even if I ping 30.30.30.1, it's not going to be captured here because here my destination is 20. So it's either I change it or maybe I use any destination, or maybe I'll just change it to 30.30.30.1. That'll be fine. I'll click on save. And let me clear my buffer. So that's fine. So let me initiate the ping now. Okay, the ping is being allowed. So now we should see it here. So you said that we refresh manually or you wait for the auto refresh, which will happen after 10 seconds. So I'll refresh manually. Okay. So let me click on this. So you can see I've been able to capture going from 10, 20, 100 to 30, 31. This is a request, this is reply, request, reply, and the rest like that. So now let me also show you how to do it via CLI. Now, one reason why I love the CLI for this. This is the same FTD 10.10.10.5. So now, you can capture from CLI, we have capture from Lina and we have capture from Snot Engine. Let me show you this. There's this document. You can just search for it. It's very good. It talks about packet capture. It's very good. So the document is prepared by some Cisco TAC engineer, by these three Cisco TAC engineers. So it's available online. It's free. Just copy. You can just Google this name. Now, if this is what I want to show you, we have the linear part of our FTD. This is where traffic is being received, ingress, and rest like that. And here we have the snot part here. So you can do linear level capture, which is from here from the linear, and you can do snot level capture, which is going to be from here. So this is the snot engine, but this is the linear, and this is the rest of the linear. So the linear is just like the normal ASA. So this is where we have the advanced inspection. So now I'll do this. Okay. So here for me to capture linear level logs, linear level packets, I'll go to System, Support, Diagnostic CLI. Just like as if I'm going to my ASA, I'll just press enter, no password there. And I'll run the command capture. The name will be CLI test. And let me do real time. Real time. And okay, before I do the real time, interface. Interface, that's going to be inside. I'm going to make it real time. I'm not storing it to any file. I'm going to show you how to do that. I just want you to understand what I'm doing. ICMP. I'm just going to say 10.10.icmp from hosts. 10.10.20.100 to host. I may not use host keyword. The destination is 30.30.30.1. But since I didn't use host keyword for a destination, just like access list, that means I have to do this that represents host 255.255.255, just like you're configuring an access list. So, and ICMP, so that's fine. So this it. And this will give me linear capture. And this, if I want to capture this from the snot engine to see if the snot engine is actually receiving the packets, I can do from here. I'll do this. I'm doing this from the diagnostic CLI, but this I'll do it from the regular FTD CLI. That will be capture traffic, enter, and the option to select is going to be one, and then I can say I'll use this command host 10, 10, 20.100. Let me just capture from 10, 10, 20.100. Okay, so that's fine. I'm going to initiate continuous ping. As you can see here now, I'm receiving the ping from my liner. This is the first phase. It passes through the liner before it goes to the access control policy, where it's going to pass through the snort engine. So the liner request is working, reply is working, and this is my snort engine also. So I can see what is happening. So this is my snort engine. You can see the request and the reply and the rest like that. So that's fine. Now, let me quickly demonstrate something. I hope you've watched. If you are watching this video, you must have seen my video where I talked about prefilter policy and access control policy. So I won't bother to do much explanation on it right now. I'll click on prefilter. This is the prefilter policy we are using for the access control policy 3. So this is the access control policy 3, which I'm using for my FTD 3. And this is a prefilter policy assigned to it. And now this is my prefilter policy. This is what I have here. My prefilter policy will permit all traffic by default. That means all non-tunnel traffic. All non-tunnel traffic is allowed. So I don't have any rule here. So non-tunnel, when I say tunnel traffic, if we are talking of tunnel traffic, I'm referring to encapsulated traffic like GRE and the rest like that. So I'm not dealing with that. So here, this default action here is for tunnel traffic. What should happen to tunnel traffic? I want them to be blocked. So if I want any tunnel traffic, maybe GRE, there's a GRE traffic flowing through, I may need to create a tunnel rule from here, or click here to add tunnel rule, or I can say, okay, I want to analyze all tunnel traffic. That means by default, all tunnel traffic, for example, let me see GRE traffic, all GRE traffic will be passed to the access control policy. So because your traffic will pass through prefilter first before getting to access control policy. So the prefilter must know what to do with the traffic. So here I didn't create any rule here to permit or to deny or to block anything. So here I'm telling my prefilter that okay, any tunnel traffic, for example GRE traffic, just push it, just send it to the access control policy. So the access control policy knows what to do, either to allow or not to allow. But here in my own case, I'm having it as block. Now for non-tunnel traffic, that is my normal IP traffic, like my ping, HTTP, this and just like that. By default, you can't change this. It is allowed. So that means even though I didn't configure any rule here, all the non-tunnel traffic will be passed to my access control policy. But if you don't want that, you can create a deny any rule. You can click on add prefilter rule and configure deny any. So that means it's going to block everything. So, but by default, is allowing all non-tunnel traffic. So that means my ICMP ping will pass through my prefilter policy and hit this default and will be passed to the access control policy. This is my prefilter policy here. So that's what this ACP is using. So and it will be passed to the access control policy. And the access control policy will also do security intelligence check, SSL inspection if configured, identity policy if configured, and the rest like that. And we also check it against all the access rules that we have here. So here I have an access rule permitting it. If I don't have any access rule permitting it, it's going to hit this default and the access control policy will drop it. So even though the prefilter did not drop it, but the access control policy will drop it. So now, I just did this expansion so that you can understand. I'm going to add a prefilter rule. I'm going to name it, let me just name it test. I'm going to click on analyze. If coming from inside, going to outside, and the network is, I'll just see any 1020 network going to any destination, that's fine. And I'll change it to fast path. Fast path, if you remember, fast path means the traffic is going to be allowed and won't be sent to the access control policy. So that means the traffic won't go through the snort engine. That's what fast path means. It will be allowed to go to the destination. So that means there's no layer 7 inspection. So I'm going to deploy this. So let's check the deployment. And again, I want to ask a question. The capture that we have on the FMC GUI, is this not capture or linear capture? I'm not going to answer that. Once our deployment is done, we'll test. Our test is going to answer that question. Okay, this is my capture. Okay, during deployment, this page is going to be unavailable. That's fine because I'm still deploying. So the page won't be available. But now, while we are doing that, let me bring up my capture. Both this is my linear on the this linear on my right hand side, and this is snot capture. So now, oh no, okay, yeah, this particular any traffic coming from 10.10.20.100, I have configured a prefilter policy that says fast path. So if 10.10.20.100 is going to any destination, it should not be sent to the access control policy. It should not go through the snot engine at all. So it should be fast path. It should go straight to the destination. So now that means once this policy has been fully deployed, I should not receive any capture from the snot engine again because I have fast path the traffic, because the traffic is no longer going through the my access control policy. So I should not receive any capture here anymore. There should not be any capture event here anymore, but I will still be receiving capture events on my linear capture because it's still going through linear. Just like your prefilter, just see your prefilter is working with the linear. Your prefilter is just like your normal ASA traditional access control policy, just based on layer 3, layer 4. So your linear is tied to the prefilter. While the snot engine is tied to the access control policy. Now 98% the policy should be effective. Now from 98%, whatever policy you deploy will be effective. As you can see from here, I'm not receiving any events. I'm not receiving any event here again because as you can see, this count is still increasing: 958, 960, 962, 964, 966. You can see it's increasing because the linear is still receiving the packet, but we've configured an access control list in the linear, telling the linear that I want you to fast path this traffic. So the traffic is no longer going through the access control policy. It's no longer going through snot engine. So that is that. So now let me also show you something. Let me clear this. I'm going to clear this. So even despite the fact that I have cleared, you can see I'm still using packet. Let me refresh again. I'm still receiving packet, you can see. So this is to tell you that the capture you have here on the FMC GUI is capture for snot engine capture. So the capture here on the FMC GUI is not level capture. Because right now, as you can confirm from the CLI, you can see here, oh, sorry, pardon me for the mix-up. I mean prefilter level capture. Prefilter, it covers up to prefilter level. As you can see, if I refresh these 26 packets, it should have increased now. I now have 110 packets. If I refresh again, I have 124 packets. So that means this, again, I rephrase my statement. So that means the capture which we have on the FMC GUI, we have the linear capture. So the FMC GUI covers the linear capture. So it's not just from the snots, it's from linear. So because as you can see, as I've been able to prove here, you can see the snort capture now. We are not receiving anything on the snort capture again, but the liner is still receiving because that's where we have our prefilter tied to. And here on our GUI, we are still receiving the capture event also, which shows that our GUI covers up to liner. So it's giving us the liner capture, also the prefilter capture is also giving us that. So it's giving us, so that's what we are getting from the FMC GUI. So now let me also, to further prove this, now I will change this back, or it's either I delete it or I'll just change it to Analyse. And what we Analyse do, Analyse means send it to the access control policy. So this rule, we do the same thing that this rule we do. This default non-tunnel traffic rule. But it's just that this one is specific to this, to this source network. So Analyse means the prefilter should allow it, but should send it to the access control policy for further inspection. So I'm going to deploy. And I'm going to monitor the deployment from here. So I'll bring this up. So our linear traffic is still going. So by the time this deployment reaches 98%, we will be, as we are receiving the traffic here on our linear engine, we will also be receiving it on our snort engine. So 95%. Once it reaches 98%, we should be receiving capture events here on our snort engine now. As you can see, now we are now receiving on our snort, because now we've changed the first part to Analyse. So Analyse means send it to the access control policy. So now that it's passing through the access control policy, we have the event here in our snort engine capture at the same time. So, and again, let me quickly show you this also before I move on. I'm going to duplicate session, still on my FTD. Oh, no. So here I'm going to run packet tracer input inside match. Sorry, input inside ICMP, coming from 10.10.20.100, going to, okay, ICMP type, that should be, I think, 0. Let me see if I get it right. And the code should be 8. And the destination should be 30.30.30.1. Oh, I used it wrong. The ICMP type 8, code 0. I'm still going to confirm that, but I think the code should be 0, 30, 30, 31. Let me see. Okay, yeah, action allow. And let me show you something here. I want to show you this capture. One. As you can see, this will capture. Okay, fine. It's allowed. Access list. It's been allowed. Route lookup. And you can see this is the prefilter policy, because once you have a prefilter rule, either you set it to Analyse or whatever, initially if you look at if you go back to the packet tracer video, what we have here is always the access control policy rule. But once you configure a prefilter policy and your traffic is hitting that prefilter policy, what you have here is going to be your prefilter policy name, which in my case is FTD3, and prefilter policy rule, which is test. I'll show you that from here. Prefilter policy. Okay, this is the prefilter policy name FTD3. This is the prefilter policy rule test. But initially, because there's no rule here, we only have the default. What you are going to see here is going to be the default, is going to be the access control policy name and rule name. But now, since we have prefilter configured and that's what our traffic is hitting before getting to access control policy, what we have here will be your prefilter policy and the prefilter rule name. And if you keep coming down, if you keep coming down, if you keep coming down, if you come down to snot, this is where you now see the snot rule. And if you look here, application unknown, that's fine. It's ICMP starting rule matching this. ICMP type is 8, ICMP code 0. Firewall allow rule is only showing us the rule ID. That's fine. And it's telling us that it's been allowed. And here you can see the route lookup, next up, and the rest like that. So that's it. Let me quickly again. Okay, you can see this is working as expected. So let me quickly do something. Let me change this to fast path again. I'll change it to fast path. And I'll run the packet tracer. I want you to see how the packet tracer is going to look like. I'm going to save. I'm going to have to deploy again. I want you to see what the packet tracer output will look like when the traffic is being fast path. So deployment 98% fine. I'll run the packet tracer command again. Now start from the beginning. Okay. Route lookup. Can see these are prefilter policy name and rule name. Inspection, okay. That's the service policy. As you can see, there is no snot inspection here. As you can see, we don't have snot inspection because it's being fast path. So you can see it's been allowed. Phase 1 here, the access list allow, route lookup allow, access list, which is the prefilter policy. It's been allowed. This is the prefilter policy name. This is the rule name. And connection settings, that's fine. That's the service policy. The NAT, phase 7 NAT session, phase 8 IP option, phase 9 inspection. That's ICMP. Because in our service policy we have ICMP being inspected. So that's why we are having this. And again, that means ICMP is being allowed, so it's being inspected. So from our inside to outside, as we are pinging, so the return traffic will return. MP, okay, that's it. Capture. As you can see here, if you look through this packet tracer output, there is no snot engine there because it's not going through snot engine at all. It's not passing through snot engine. So if I do same for HTTP, TCP 10.10.20.100 and 1000 as a source port, 10.20.20.20.1 and 80 as a destination port. So if you look from here, this is for the HTTP. So here for HTTP, you can see this is a policy name. As you can see, it's not going through this not engine. I quickly want to show you two more things before I wrap up this video. Now I'm going to do this. I'll change it back to Analyze, just two more tests. I want to show you how the HTTP packet tracer outputs, what it's going to look like if it's passing through access control policy. Okay, 98%, that's fine. So now we are sending back to access control policy. So I want you to see how the packet tracer, for HTTP will look. What it's going to look like. Now the capture is being allowed, fine. Access list is allowed. Route lookup, that's fine. And here you can see Prefilter Policy and the rule is still test, that's fine. And here now we are going to see the snot section. You can see that external inspect snot, and this is the snot part. And see firewall allow rule ID, and it's been allowed, so that is that. And again, if it is being blocked, for example, I'll delete this and let me go to the access control policy. Let me block it from the access control policy. I'm going to change this to block. So since I'm blocking, login will only be done at beginning. Okay, that's fine. Do I have intrusion? Okay, yeah, fine. Intrusion policy. Yeah, okay. It's been created out. Okay, let me change this to allow. I'm going to change this to none. So that's fine. So I'll change it back to block. Save. Save. Deploy. Just want to see what the output will always look like. So I'm deploying. So right now, for the prefilter, we check. For the prefilter now, I've deleted all the rules. So now my traffic will hit the default non-tunnel traffic is allowed. That means it's going to be sent to the access control policy. And this will be the access control policy. And definitely the access control policy is going to block the traffic on the long run because it's going to hit this. Oh no. Okay, I'll use the ICMP. I'll use the ICMP for example. Come back to packet tracer. because deployment is still on. I wanted to use the HTTP for example, but I only blocked ICMP. I wanted to block HTTP, but I blocked ICMP, so that's fine. I'll use that for the demo.